Let's find a general solution using separation of variable. The first step to do the separation is you have to use factor by groups. So for factor by groups, there are 4 terms. You have to group the first 2 terms, and then you have to group the last 2 terms. There are some booby traps when you do factor by groups if the problem is like this: t squared times p minus t squared minus 1. So if the sign between the 2 parentheses is minus, so when you group the first 2 terms and the last 2 terms, you have to change the minus 1 to a plus 1. This plus 1, because when you distribute the minus, you have your minus t squared, and then you have your minus 1 back. And then second of all, if your instructor decide to ask you to do factor by groups on the exam, maybe your instructor won't put these 4 terms in this order. If they shuffle up the position of these 4 terms, the separation of the factor by groups might not work. So if you see 4 terms and you know that might be a factor by group problem, try to rearrange the position a little bit to see if you can do factor by groups. So let's say in this problem, if they interchange the position of the minus p and the minus 1, then the factor by groups might not work. So this one, how do we do factor by group? So the first parenthesis, I would like to factor out a p. So we have dp dt equals to p times t squared minus 1. And then do you see that there is another t minus 1? So that means my factor by groups is successful. And then you have nothing to take out. So why don't you just put a 1 right there for our next step? And then for the next step, so since they both have a t squared minus 1, I'm going to factor out the t squared minus 1. And then if you just cover up the t squared minus 1, what else do you see? You see a p plus 1, right? Right? So now we have 2 factors. One has a t in it, the other one has a p in it. So the factor by groups is done and successful. And then dp dt. So let's move the t to the right hand side and the p stays on the left hand side. So we multiply both sides by dt. So when we do that, we will just move the t to the other side. So since that is back to separation of variable, I will just go back to that color. And then before I do so, I would like to label this factor by group. So this is factor by groups. All right, so let's go back to that color. So we have dp equals to t squared minus 1 and then times p minus 1, and then we have a dt. So since dp is on the left side, let's divide p plus 1 on both sides. So we have 1 over p plus 1, and then dp equals to t squared plus 1 minus 1, and then dt. So now all the p's on the left or the t's on the right, you can integrate both sides. Okay, so let's integrate both sides. So we integral and then integral, and then on the left hand side, so this one you can do a quick u substitution, but I expect you to be able to integrate without a u substitution. The answer is just ln, absolute value of p plus 1. If you want me to show you the u substitution, you have to let u equals to p plus 1 and then du equals to dp. So that's how you get a 1 over u, integral of 1 over u. Maybe let me just show you the step, right? Because if I don't and you don't get it, you might have to spend 10 minutes to figure out what I did. So we have integral 1 divided by u du, and then that gives me ln, absolute value of p plus 1, right? And then what about the t squared minus 1? The t squared minus 1 is just a simple power rule. The integral of t squared is 1 third, t to the third. The integral of 1 is equals to t, and then you stick a c to it. All right, and then how do you take the p plus 1 out of the ln? You have to remind yourself that there is a base e in the ln. So there is a base e. So let's do it right here. So there is a base e, and then you will have to take the base e and then put the entire right hand side in the exponent. So this is how we do it. So we have base e. Oh, actually, should I put it like this? Okay, let's just keep the p plus 1 in here. And then we have the base e raise the entire right hand side. So 1 third, t to the third minus t, and then plus c. Okay, and then the next thing is, do you still remember this? If you have x to the n times x to the m, that is equals to x to the m plus m. If you have e to the n times e to the m, that is equals to e to the n plus m. So I'm going to have to separate the plus c to what? So p plus 1 equals to e to the, don't touch the t, so we have a 1/3 t to the third minus t, and then multiply e to the c, and then e to the c is just a constant c. So this one is just a constant c. So this is just a constant c. When you do differential equation, listen to this. A constant is a constant. It doesn't matter how you express the constant. Again, a constant is a constant. It doesn't matter how you express the constant. So e to the c is just a constant value. So we will just take whatever in front of it, multiply a big C. So therefore, we have p plus 1 equals to a big C times e to the 1/3 t to the third minus t. And then this one you can subtract 1 on both sides if you want to solve explicitly for p. So you can do p equals to ce 1/3 t to the third minus t, and then minus 1. So this is your general solution, and you, okay, let's make the box bigger. So this is your general solution, and you solve explicitly for p. So you solve, so this is a general solution, and then you solved explicitly for p. That means you have p stands alone on one side, clean, equals to a bunch of t and constant on the other side. That's what do you mean by solve explicitly for p. All right, so that is the end of this problem and this video. If you think my instruction is clear and helpful, share the video for me, click the like, click the subscribe if you're on your way out. I will catch you all in the next lesson. Signing out.